Let's build a VirtualBox penetration testing lab. First of all, let's have a look at the design of the virtual lab we're building. We'll need a machine to run our Kali Linux system, together with its test tools. We'll need a target to test, and we can set up another virtual machine and load it with the Metasploitable Linux distribution. This is a distribution of Linux which is deliberately insecure and designed to be used for security training purposes. We'll set up a standard Linux host to test against. And we'll also want a Windows target, which we can get using a fully functional Windows 11 system, downloaded from the Microsoft website. VirtualBox provides a virtual network to connect these systems to form our testing lab. It also provides the network translation across a virtual gateway, enabling these services to connect to the internet if required. Okay, let's start the setup. VirtualBox is available from the virtualbox.org website. On the left we can see the links to downloads and documentation, and on the right the latest news. We'll select Downloads, and we'll get the appropriate VirtualBox system for our host environment. We're on a Windows 10 system, so we'll use the platform package for Windows hosts. I've already downloaded the VirtualBox package and installed it using its default options. If you're following along on your own system, then take a pause to do that. Here's our brand new installation of VirtualBox, ready to go. At the top we have the VirtualBox menu items, File, Machine and Help. These are used to manage the VirtualBox system. Below them we have the Tools menu. And to the right are the 5 common actions we'll be taking as we use the lab. Preferences, to set up the configuration of virtual machines. Import, to load a new virtual appliance in virtual machine format. And export, to save a copy of a virtual machine. New, to load an empty server and install an operating system. And add, to set a new virtual machine up from a VirtualBox configuration file. Okay, we've now got the foundation of our test lab, and we're ready to go. In this course, we'll set up and do security testing in a virtual lab. To create the lab, we'll use a virtualization system called VirtualBox, which will run on a Windows 10 host computer. We'll use a Kali Linux virtual machine to do the testing, and we'll load some target systems into the lab. There are a number of advantages to using a virtual test lab. Virtualization is a very easy way of setting up a testing environment, and avoids the need to purchase racks of computers and networking equipment. I'm using an i7 Shuttle PC to run a virtual test lab. But with the efficiency of modern virtual environments, almost any computer with enough memory is powerful enough to do this. 8 GB is sufficient, but I like to run on a 16 GB system. Using a virtual lab for testing ensures that all testing is contained within a prescribed environment, so that we minimize the risk of test scans and probes leaking out onto the internet, and avoid our legitimate testing activities inadvertently becoming illegal activities. This is an important consideration in all aspects of penetration testing. Virtualization is not only a simple and safe way to do testing, but it also offers a further advantage when dealing with potentially dangerous tools. Using a virtual environment, a tester can take a copy of a known good state and save it as a snapshot. After running a testing session, the snapshot can be used to recover the lab and remove any malware or traces of malicious activity. Before we go any further, let's look at what we mean by virtualization. The basic structure of a normal computer is a hardware layer, on top of which sits the operating system. The operating system directly interacts with the computer hardware and controls how the hardware is accessed. On top of the operating system are the various applications which use operating services and, through them, the hardware resources. For a native or hardware level virtualized system, there's another layer, the hypervisor, which sits on top of the hardware. This provides a virtual set of hardware on top of which sits the operating system and its applications. Using the hypervisor enables multiple operating and application system stacks to operate. These are called virtual machines, or VMs. The hypervisor manages the virtualization of input-output services, mapping devices in the virtual machine to the hardware devices and managing contention. An example of this is the Microsoft Hyper-V hypervisor, which was introduced with Windows Server 2008. Another example is the Proxmox Virtual Machine Manager. Native hypervisors are installed prior to installation of any operating systems. The hypervisor includes a Virtual Machine Manager, or VMM, which can be used to stop and start virtual machines and to configure how they operate. In the case of Hyper-V, the hypervisor management sits in what's known as the parent partition, and guest operating systems sit in child partitions. VMs don't have direct access to hardware resources. The VMM service in the parent partition is responsible for all access to hardware devices and manages access on behalf of all VMs. A VM hardware request is redirected by its virtualized service client across the VM bus to the appropriate device in the parent partition. Software virtualization is another approach that can be used. In this approach, the virtualization manager operates as a standard application on top of a host operating system. To do this, any privileged operations within the operating system must be carried out by a VM-safe routine in hypervisor memory. This is achieved by a module in VirtualBox called the Code Scanning and Analysis Manager, working in conjunction with a real-time patch manager which identifies and replaces unsafe code with safe code routines. Processors such as the Intel VTX include hardware-assisted virtualization to enable virtual machines to maintain their own address space and deliver additional performance. Two popular software-assisted virtualization systems for Windows are VMware and Oracle's VirtualBox. Parallels is a popular virtualization environment for Mac systems, often used to enable Windows functionality on Mac computers. In this course, we'll be using VirtualBox. VirtualBox is free for personal use. It's available for the x86 type of processors and runs on a range of operating systems including Windows, Linux, Macintosh and Solaris. The base package comes as a free download and contains everything we need to run a virtual environment. An extension pack is also available, which includes extra features. To learn more about virtualization, take a look at the virtualization courses available in the LinkedIn Learning Library. Let's look at the File menu option. This provides the functions associated with managing the virtualization and importing and exporting appliances. The first item is Preferences. Selecting Preferences brings up a pane for setting the virtualization configuration. The first general drop-down box allows us to specify the folder where we'll store our virtual machines, which we can leave as default. The second is the VirtualBox Remote Display Protocol Authentication, which is used when accessing virtual machines remotely. This protocol is similar to RDP. We won't be using remote access, so the default's fine. The next Preferences function is Input. This is used to set the various virtualization manager and virtual machine host keys. Note on the Virtual Machine tab, the first entry is the right control key, which is called the host key. Further down we can see the Insert Ctrl-Alt-Del command, which we can see here is activated on the virtual machine by using host plus del. So right Ctrl and del pressed together when in a virtual machine will cause the virtual machine to behave as if Ctrl-Alt-Del had been pressed. Another useful virtual machine command is take snapshot, which we can see is host plus T. We won't go through these in detail, but you might want to pause the course for a moment and familiarize yourself with the various key combinations. When the Auto Capture Keyboard checkbox at the bottom of this panel is checked, then the keyboard input will go to the virtual machine if the cursor is in the virtual machine window. This is really useful, so we'll leave it set. The next function is Update, which configures VirtualBox to check for updates and allows the frequency and type of update to be set. We'll leave this unset for the moment. The language defaults to English, and this is fine. The display setting allows the screen size of a guest operating system to be specified. We'll leave this as automatic. The checkbox for raising machine windows can be left unchecked. We don't need to configure a proxy server, so we'll leave this as auto detect. We can change our interface scheme to be light, dark, or, as it's currently set, to follow our system settings. We'll leave this as it is. OK, that's Preferences set up. Let's go back to the File menu. The next two options are to import and export an appliance. In VirtualBox terms, an appliance is a full copy of a virtual machine that's ready to go. The OVF standard is supported by many virtualization products, and there are lots of pre-configured virtual machines available for download from the VirtualBox website and other locations on the internet. OVF appliances come in two formats. The first is as multiple virtual machine disk files which have a VMDK extension and an associated XML file with an OVF extension which connects them together. The second format is a single packed Open Virtual Appliance file, which is a single file with an OVA extension. These are what we'll use as we set up our virtual testing lab. The next option in the File menu is the Tools submenu, which we'll cover shortly. We also have an option to manually check for updates to the VirtualBox system and an option to clear all warnings. Selecting the File Tools submenu gives us the same options as selecting the Tools item shown at the top of the left-hand pane. When we open the Options menu, we have a Welcome page, which is where we're at, and 5 tools we can use. The first tool is the Extensions Pack Manager, which shows we have an extension pack loaded and active. This provides our virtual machines with useful capabilities such as cut and paste. The next tool is the Virtual Media Manager, and this provides a summary of the virtual hard disks, DVD drives and floppy disks associated with each image. We'll skip these for the moment as we don't have any VMs installed yet. The Host Network Manager is the next tool, and this allows us to set our networking configuration. We can operate our virtual machines using one of 3 types of network. The host-only network allows VMs to connect to other VMs, but not to connect to any systems outside of the host-only network. Here we have a host-only network set up with VirtualBox having the network address 169.254.240.169 and with a network submask of 255.255.0.0, which means our VMs can be assigned addresses in the Class B subnet starting 169.254. If we run ipconfig, we can see that we have indeed been provisioned with the address 169.254.19.129. We won't be using host-only networking, so we'll leave this configuration as is. Note that the DHCP server is disabled, so our VMs won't be automatically provisioned with host-only addresses. The next option for networking is the one we'll be using, which is NAT networks. We can see that the DHCP server is enabled, and that it will provision an IPv4 address using the smaller subnet with address prefix 10.0.2, allowing for 256 VMs. We won't get an IPv6 address provisioned automatically, but if we wanted one, we could check the box at the bottom left. We don't, so we won't. The NAT network mode offers more flexibilities, as VMs can access not only other VMs in the NAT network, but also any systems on the host network or, through the host network, the internet. However, other systems on the host network can't initiate connections to VMs on our NAT network. We could change the name of this network, and in fact we may want to do so if we're setting up multiple NAT networks. But for our lab we're not, so we'll keep the default name. Note that we have network create and remove options at the top of the screen, and that these are also duplicated in the left-hand network menu item. We can press create and we get a new network created with the name NAT Network 1. If we were to use this, we might want to give it a different subnet range. However, we don't want a second network, so let's just remove it. The Properties control just removes or reinstates the network properties. We won't be using cloud systems, so we'll skip the Cloud Networks tab. The Activities option provides a dashboard showing the CPU, RAM and file system load that VirtualBox is placing on our system. We'll want to monitor this as we start using VMs to ensure we're not overloading the system. The Machine menu item is used to manage virtual machines, which we'll leave for the moment, as we'll come back to it when we start loading our systems. We'll see more options in VirtualBox once we load our virtual machines, but that's pretty much all we need to understand about VirtualBox as we start setting up our lab.